Welcome everyone. So today we are going to talk about the one of the recent scenario or the development that is happening uh, between US, Israel, and Iran. So for that, I have done some research. I have collected some data from Kaggle and different sources regarding the current ongoing scenarios. So in that, the title and that thing we are going to means handle through the deep learning models. And the title of the work is GeoWarFM, and this is basically doing a structural encoding of the geopolitical risk. And now we will start. So the outline of this work will be like this. I'll discuss it first. So first of all, we are going to talk about the problem statement and the research gap, and then we will be talking about the GeoWar energy bench dataset that I have collected, and then architecture that has been developed, and the forecasting heads and the results will be discussed. Out of the results, the main issue is the what are the inferences that will be discussed, and the case study. There will be empirical validations also, the casual simulators, and then we will be talking, end up with the conclusion and the future scope. What else can be done? So the main problem statement is that the current ongoing scenario has been of the war scenario has means impacted everyone. Every country is getting impacted, and there is no such a foundation model that has the understanding of simulation of the energy consequences of the geopolitical conflict that is going on. Can be dealt with. So we are going to miss ultimately develop a foundational model for understanding and simulating the energy consequences of the geopolitical conflicts. And we have the training data set from 1948 till 2026. And the things that we are going to discuss is not theoretical. Basically, it's empirical. So we have tested whether the conflict severity correlates with the inflation using the 78 years record, as I have already told that from 1948 to 2026. And we will be having the uh, some features like military expenditure, GDP growth, inflation rate, conflict severity index. We will be running the Pearson correlation across the series of the data, and then we will try to point this the existing means existing oil price forecasting model street wars as the exogenous noise. So they model the price as a function of price, lagged values, volatility clustering. So without structurally encoding the military and maritime events that caused the shock at the first place. So this gap we will try to fill up with our work. The title that I have already given, that is GeoWarFM. So this is the thing that we are going to discuss. Now we will move to the first slide. So this is the blind spot in the traditional energy forecasting. Here you can see from um, 1948 to 2020, the inflation rates are discussed. You can see that from the Gulf War, and from the Gulf War, then you can see the Yom Kippur War, then Korean War, the US-Iran conflict that is going on. So, how this energy is impacting, energy crisis is impacting the inflation that has been drawn in this particular graph. So, what is the flaw in the existing system? They means only been designed purely to predict the uh, prices of the fuel purely on the basis of the logged value and the clusters from where it is getting generated, and the volatility. right? They are means they are not means treated as per the war. So here we are trying to means figure out some structural encoding between the data set that we are having, and we will try to means develop a model which can structurally deal with all these things and develop and produce the forecasting results. So this is the basic understanding that I have tried to develop for you. So the data set that has been taken, that 30% of the data set is from the energy sector. That is crude oil annual report that has been taken. It is having 12 observations. Then we have the maritime data set, the basically the Strait of Hormuz problem. This means disruption, and because of that, what are the problems that is happening? So we are having 70 transit record for that, and then we are having the how means this is the specific to the this maritime data set that is having 25% of the entire data set ratio. Now we have another maritime data set that is having 18%. Means this is specific to the Strait of the Hormuz, and this is the maritime data set is for the countries those are getting affected. The policy is 16%, and the spatial data set is the 11%. So every data point tries to trace sources has been means discussed here, and now we are going to talk about the model that has been developed. So we have created an architecture. This is the architecture that we are going to talk about. So basically, it is having some since we are trying to make some encoding of the war scenario that can be that can take the raw data set. Raw data set and can be structured that can predict the outcome, not just basis of the some regular features, but on the basis of the ongoing scenarios. So this is the architecture. So it is having the event encoder, then we have the temporal encoder, maritime encoder, and then we are having the policy encoder, the spatial encoder. So these are the encoders, and they are means that the data has been transferred to the cross model transformer, and 512 dimension universal crisis embedding has been generated. So now I'm going to talk about each of these one by one. So, if you see the Geo War Farmer is having the five parallel encoders, and they are feeding to one fusion layer. So the event encoder processes the war event text using the long former, or you can say the BERT architecture. Now, the temporal encoder means processes the oil crude prices, crude prices, the series of the data set, right? The Cornos and temporal fusion in the transformer style. Then data is passed. The another data that maritime encoder processes the state of the Hormuz, the transit counts in the same way. These are three feed to the secondary encoders, the policy encoder for the tax subsidy structure, and the spatial encoder using the dynamic heterogeneous graph transformer over the country level important dependency graph. So this is what we are taking. So all five output converge to the cross model transformer. The attention is calculated jointly across the events, temporal, maritime, policy, and spatial representation. And this produces what we call the universal crisis embedding, right? This is a over 512 dimension vector per country observation that has been means calculated. And in our working the implementation, we approximate this fusion with the future concatenation plus MLP projection to a 16 dimension embedding for the tractable proxy of the full architecture, right? So running this over the 14 countries policy spatial data set, and the resulting crisis scores ranks the different countries. Like Pakistan is having 4.194, followed by India 2.96, 2.96 97 basically, and then Bangladesh. So countries are getting impacted. This is coming through the crisis encoder. From this embedding, the three heads branch out: the forecasting and the risk assessment and the casual simulation. I'll walk you through the performance of the each. So now we are going to talk about the three means the heads that I have discussed just now. The forecasting head, the first of all, if you see this particular diagram, the forecasting head, the gradient boosting regression, the annual crude price, and then R2 square as the evaluation matrix. Then we have the risk assessment head, that is having the multi-layer perceptron classification, and then it is having the vulnerability tiers like critical, higher, and moderate level. Then what accuracy that has been achieved, that is also discussed. Then casual simulator head, we are having in that the structural casual Monte Carlo method has been implemented over the 150 to 200 samples. Counterfactual shock trajectories has been tried to means figure out, and then the policy sensitive mapping has been done in this particular head, and ultimately structural ordering intervenes. Uh, Invariance has been means calculated. The forecasting head, if we go one by one. So forecasting has the gradient boosting regression traced over the five features, right? It is having the military expenditure, inflation rate, GDP growth, conflict severity over over and over a year price change, predicting the annual crude price. So it is trained with the 80-20 ratio, um, split over the annual series, and where n equal to 12. I want to flag this sample honestly because this it constrains confidence. The model achieves mean absolute error of $6.80 per barrel, and root mean square error is at $10.29 per barrel, and R2 square is 0.58. That R2 square means the model explains 75%, 75.8% of the year-to-year variance in a crude oil price using only conflict and macroeconomics covariance, no lagged price terms. The feature importance plot shown here in the next slide. Let me show you first. Show you first. So here, the forecasting head that I'm talking about. What that is what I am discussing right now. Like 75% of the model is able to 75.8% year-to-year variance is able to means explained by the model, right? And the feature importance plot shown. The conflict severity index and the inflation rate as the two highest weighted predictors ahead of the GDP growth and the military expenditure of means around any country. This is the two very important features that has been highlighted through the R square of this particular head. We ran this forward trajectory simulation starting from the $68 per barrel conflict severity 9 out of 10 Hormuz closed, and the model exponential decay shock function project the 20 days peak of the approximately around $78. I'll address why this underestimates the observed 104.25 peak when it gets casual simulator. The short answer is that the trajectory function here does not incorporate with the SPR release and the LNG shutdown in terms of the casual model does. What casual model does. This is what the this particular head works, right? Next head is now we are going to talk about the next head. Uh, this is the vulnerability risk means classifier. That is what we are going to discuss now. And this head is a multi-layer perceptron classifier for the countries into four vulnerabilities: critical, high, moderate, low, using the oil import dependency, GDP impact, stock market changes, and the crisis as the input. Trained and tested over across 17 countries, model achieves more than 80% accuracy with the micro average F1 around 83%. So confusion matrix in this year shows indicates that the classifier correctly separates the critical tier countries like Pakistan, Sri Lanka from the lower tier oil exporters. Low tier oil exporters like Saudi Arabia and UAE with no cross tier crisis. Those extremes means misclassification, yes, definitely. Where it occurs, it concentrated in the moderate to high boundary, which is expected failure mode when now when what we can say that given how to choose those two classes in the feature space. So means out of sample test prediction confirms that the Pakistan classifies critical, Sri Lanka classifies critical, Germany classifies as the moderate. Um, Saudi classifies as low. All consistent with the ground truth label that has been provided in the data set. So means if we talk about the results and we try to justify it, so 80% of the accuracy is the only meaningful related to the baseline. The majority class is baseline here, always predicting the most common tier, which is high, would roughly 41% on the 17 countries set. Since high counts 7 out of 17, the classifier 80%. Therefore, the substantial improvement over the naive gain, guessing not a result inflated by the class imbalance. Second, the specific errors are diagnosed reasonably rather reasonable rather than the random. So every misclassification observed on the sets of the moderate to high. So they are constructed as the as held out test cases with the values drawn from, but not identical to the train distribution, which is a deliberate generalization check rather than the training set accuracy. It means we cannot fix. We are not fixing it. Rather, we are deliberately doing this generalization. Okay, so then we have if you see this, so this case study, right? We are now moving to this particular slide. So here you can see that there is no now the empirical centerpiece we are going to talk about. The US-Iran conflict is used as the out of sample event validation, and the two checkpoints supporting this particular reading of the graph is this the actual signal rather than the confidence. The first temporal precedence is unambiguous transit. Collapse and the closure of the announcement occur on the same day on February 28, 2026. The price the responses follow the within the same trading season. The ordering rules out the alternative explanation of that the price were driving the closer discussion. Or the you can say that closer discussion or the decision than the reverse. So second relationship that has been shown here, the that is dependent relationship that we are going to find out from the initial drop of the 12 ships, then the single digit ships that has been transited through the Strait of the Hormuz. The price continues to climbing in the proportion rather than the jumping at once, and a single co-founder producing that one-time label shift would be not reproduce is the graded co-movement across the multiple subsequent days. So third of this pattern replicates the mechanism already documented in the 1973 embargo and 1990 the Gulf War, the data set from World History Economics from 1948 to 2026 shows both conflicts severity spikes co-occurring the inflation spikes in the same year. So the 2026 maritime prices linkage is consistent, not with outlier that 78 years historical pattern showing the segment. So this is what we have shown in this particular slide. This is the counterfactual sandboxes, like okay, how the prices has been increased. over the days, from day one. Okay, it's not a single day it become plateau. Rather, day by day the prices has been increased, and here you can say the pattern, right? So from $68 till $111, $111.7. So pre-war this was zero till $43.7. That has been increased, and that has been means achieved through the that had been understood through this risk transformer, the risk model that we have created, the universal risk transform. Right. So the policy intervention, the last one, uh, if we talk about. So this basically showing that the model computes $19 delta for no SPR scenario, right? And the specific magnitude you can see here, this from this particular thing, right? Independently collaborated. Uh, by the directional impact that estimates the IA directional, and Goldman Sachs is validating the simulator scaling. So this is what this particular slide is showing. Then, if we come to this particular slide, then we can see the how GDP is impacted due to this war for different countries. Again, this is calculated through the model that I have. This particular model has understood this, and means okay. This thing okay already means in place, but the model is also able to understand and tries to figure out the import dependency versus price increase through the different parameters. So the GeoWarFM maps the singular global price shock into highly localized heterogeneous economic damage based on the precise national import dependency technologies or topologies. This is what it is showing. So this is the audit that we have done. So the model is producing 75 or explaining is able to explain 75.8%. Um, uh, uh, the issues 80% accuracy risk, it is able to calculate the correctly, and then policy and all. So the empirical results are validated through this. Here the methodological parameters are showing, and this is the justification which I have already given. So thank you very much. With this means ultimately I want to conclude here that okay, since we have one parameter for the crude oil pricing, one parameter for the Strait of Hormuz impact, one data set for the different wars, but we don't have a unified solution. So this particular model, this particular transformer based model gives us the solution which can take the events, temporal parameters, maritime encoding, maritime data set, then we have the policies, then we have the spatial encoder. So we can combine into a cross model transformer that can produce a result which will be helpful for the everyone to means a unified model that can fuse all these encoders and produce one combined result. So this was missing in the research domain. This was the research gap. Hypothesis was that we have transformer based model, or the transformer based model can produce the better results in comparison to the doing the singular analysis or individual analysis. So this particular model is doing the fusion and doing the better analysis, or not doing the better analysis, but it is combining, not only doing the better analysis, rather or we can say that it is providing us the better results as compared to doing, because connecting the thread is one thing, but combining the thread and processing it through a model is a different thing, and that for that this model is sufficient for. So thank you very much.